Let's move on. Calculate, 23. Calculate the concentration of hydroxide in a solution that contains 3.9 times 10 to the minus 4th molar hydronium. Okay, that could just as well say hydrogen ion. Take your choice, because we use those two interchangeably. And we're at 25 degrees, and we really don't care about that either. Then we want the hydroxide ion concentration, and we want to know, is it acidic, basic, or neutral? Okay, this is kind of similar to that last one, except this thing is going on, whether you're in acid or base or anything. As long as you're in water solution, Kw is always doing its thing. And so, since we're working at standard temperature now of 25, we have to know this Kw is 1.0 times 10 to the minus 14. Well, we know we're given here what the hydronium is. 3.9 times 10 to the minus 4th. Okay, I can have an X here because we know the Kw. So we're just looking for hydroxide. And so divide both sides through by this, solve for X, and that will be hydroxide. And let's see, I believe we get 2.6 times 10 to the minus 11. And then you have to decide, are you acid or are you basic? Remember that table? Okay. Okay, if they're equal to each other, are we acidic? Are we neutral? Are we basic?
Neutral.
Neutral. In this case, what are we? We're acidic. And in this case, then we must be basic. Okay, when you see what the hydronium ion is, and we just solved and got 2.6 times 10 to the minus 11 for the base. Okay, so it's either going to be answer B or E. Which is it? Are we acid or are we base? We're acid, because 3.9 times 10 to the minus 4th is a lot bigger than 2.6 times 10 to the minus 11. Remember, negative powers here means tiny, tiny, tiny. Are we right? You guys look exhausted. I don't see believers out there. Maybe, if I didn't miscount. Okay, now, first of all, did you get the 2.6 times 10 to the minus 11? Yes. Everybody's good with the math. Okay, now, the reasoning part of it. Which is larger? Well, if this doesn't convince you, if you're not comfortable with this, switch it into regular notation, and then it's not an issue, really. But be careful, if these had been positive in some other problem, we got another story totally. So, since this is the bigger of the two, remember, whatever we have more of, if we have more hydrogen ions in this, then we're acidic. So, we have here, and I think probably what confuse people is they are asking for the concentration of the hydroxide, you get it, and then you have to turn around and say acidic. And that doesn't seem like that should go together. Okay? It's like that psychology test when they show the word blue, but they show you something yellow, and your brain just can't cope with that because you're reading one and seeing the other. Well, I think that was the issue here. Okay, we okay? Yeah, Jerry.
Sorry.
No, don't be sorry.
How do we get to 2.6 times 10 to the negative 11?
Okay. Let's see, we're right back over here. We were told, first of all, KW we memorize when we're at 25. So we know this. We are given this. And we know in water, or in any aqueous solution, you can have the strongest acid in the world, you will still have a trace of hydroxide because you're in water. You can have the strongest base in the world, and you'll still have a trace of hydrogen ion. Okay, the product of these two is going to be equal to this, no matter what you got. They tell us we have this much hydrogen ion. Okay, so we'll solve for it. Well then, how much of this will we have? So when you move that around,
I didn't see that over that side of the board. I was staring over here.
Oh, okay.
I'm so sorry.
Oh, no problem, no problem. Okay. Determine the pH of a 0.461 molar, and then that's benzoic acid, but don't sweat the name. All you have to know is that it must be a weak acid. The Ka is this, for this stuff. Now, how much you recognize it as an acid? Organic acids, remember, have the COOH or CO2H cluster there. And then we also see Ka written here. So we know it's a weak acid. So as soon as you know it's a weak acid, here's what I would do. Step 1. Call your weak acid HA. You don't want to have to deal with that benzoic acid and have the real formula there. It's just too confusing. So if you'll do your weak acids this way, there's your step 1, always, always, always. And then step 2, Ka is always written like this. Okay, now let's see. Ice table, probably. So, do you see how much I've done without really thinking at all? I need this equation. I need my Ka expression. And then I'm going to need an ice table. Now I look at what I've got here. Okay, Ka is given as 6.5 times 10 to the minus 50. Okay, so I take that out of the problem. And it sounds like it's going to dump rain. We're going to work for about 15 more minutes. If you want to bail out and get to your car before it dumps out there, feel free. But otherwise, I'm going to work for about 15. I don't have to leave. That's why I don't care. Okay? All right, well, let's go on. You are tough. Just don't get struck with lightning. Or if you do get struck before the test, not after the test. Okay, now what else do we know? We know it has a pH of, well, I can't read up here.
We don't determine.
Oh,
pH.
it determined the pH. I should look down here instead of. Okay, so we've got the Ka, so we want to know what the pH is. So let me go back and actually read this. determine the pH of 0.461 molar. Remember when we hit the chapter on the acids and the bases, that I think that's chapter 16, if I remember, 15 or 16, that if they give you the concentration of an acid or a weak base, that's going to be initial, even though they don't say that nicely, that it's going to be initial. And then if they ask you for pH, that's going to be equilibrium. It's got to be. Because at time 0, this hasn't started yet. So we're not going to actually have a pH reading in water. But at that hypothetical instant, you can't get your probe down there and take it fast enough. So let's go through here. What do we assume this is at time 0? 0 and 0. Okay, now, am I going to have an X in here? Why? We have the K. So, since we're looking for pH, let's choose this to be X. Okay, so we're going to make X of the hydrogen ion, so we end up with X of the hydrogen ion. And the little tiny contribution from the water doesn't count. It's such a tiny amount. Okay, every time I make X of this, how much of this do I make? Same thing, X. Because every time you make one, you make one. Okay, and then how much of this do I use? X. Okay. So this is going to be at equilibrium, 0.461 minus.
Wasn't that, it needed to be times 10 to the -6 to be discounted? To the -3rd?
Yeah, if Ka is less than 10 to the -3rd, if X is an equilibrium of value, it's going to be small. And so my next question is going to be, do we expect X to be big or little? You read my mind. So we expect it to be little. And so why don't we just clean it up right here and just say, why don't we omit that? Yes.
Smaller than -3.
Yeah, that is one of the many Cartwright rules. Like, you may not wear a prom dress cut down to your waist. That's another Cartwright. Okay, and even if it has flesh-colored fabric under it, you still. That's been the battle at home recently. Okay, so we have X squared up here, 0.461 minus X, but the X is going out of there. And so just this times this, and then take a square root. Try it. And then X is going to be the hydrogen ion, but we're not done yet. If they had been a little nicer to us, they would have just said, what's the hydrogen ion in the story? But they're not. Okay, so hydrogen ions, anybody have it? 0.00547. Okay, and that's molar. So what other folks got?
Yes.
Okay, then we need to get to pH. Remember, pH is equal to minus the log of the hydrogen ion concentration. So again, get comfortable with your calculator. So you're going to have, on mine it goes, give a negative, give that change sign button, and then log, and then punch that number. Now, other calculators have a different order of operation. Or also, you can do a second function answer and go direct without having to write it down and re-enter it. So what are we getting for pH here? 2.26? Okay. 2.26, and is there answer C, as in cat? Okay, are we good? All right. Number 25. Determine the pOH of 0.188 molar ammonia solution at 25. The Kb, we know it's a weak base, even if you'd forgotten ammonia and ammonia's cousins are weak bases that we use. Kb is 1.76 times 10 to the minus 5. Okay, I read that much, and I say, okay, we are up against a Kb problem. But are we settled on this before I move on? Erase? Yeah, Hunter?
You said whatever acid we were dealing with was a weak acid, but it gave a pretty low
but pHs are really, it depends how concentrated something is and whether it's strong or whether it's weak. And actually, the pH scale is for mostly pretty dilute acids. I mean, if you had concentrated hydrochloric, you would eat up your pH probe if you stuck it down. So, yeah, I mean, we're sitting here with stomach contents at about pH of 1, and we live. So, yeah, the lower you go, the more hydrogen ion you have, but it doesn't necessarily on that pH scale mean that's hazardous, real hazardous. Mm-hmm. You're drinking like orange juice or apple juice, pH 3. We live through that, without any damage. So it's the pH scale. Yeah, I know we say go down around 1 or 2. It's pretty acidic. Well, everything in life is well. Okay, now let's see. We're back here with the KB problem. So I realize it's going to be a KB problem, and so without even thinking what I'm going to have to do ultimately, I'm going to go ahead and use ammonia instead of the general case. I'll show it both ways, but remember with the weak bases, you have to include the water in there, and in this one, I'm going to get ammonium ion plus hydroxide. Or, if you prefer, you can just say this is the base. I've got to add water. Now, do you see the difference? Over there with a weak acid, I could put the water in if I wanted to. And if I wanted to, I'd stick it in and then it'd become hydronium. But we wouldn't put the water in the K. It's really not needed over there, but it is needed here with the weak base because your source of hydroxide is actually the water. Okay, this is the general case, but because we work with ammonia so many times, I usually just go ahead and write out the whole thing. So here's my step 1. I need the equation. Step 2. Okay, there's step 2. Okay. Okay, what do we know? This is 0.188, and it tells us here the KB is 1.76 times 10 to the minus 5. You see how this is so similar to this one? That this is a weak acid, and they gave us the Ka, and they asked us for pH. Okay, now we turn right around. We have a weak base. It gives us the Kb, but it's asking for pOH. Everything is going to be basically the same. How much of this ammonium do I have when we start? 0. And hydroxide? 0. The little tiny bit we get from the water is so little we don't even consider it. Okay, now, may I have an X? Yes, I can, because we know this. Okay, so why not? We get our may, we get our may, we get our U's. The nice part about weak acids and weak bases, all coefficients are 1. And so it's not quite the brain strain of that stuff in the previous chapter. Okay, so we're making X, we're using X. Now, can I trash this X? It's okay too? Why? Okay, our K is less than 10 to the minus 3rd, so why don't we just omit it right there? So we have here 1.76 times 10 to the minus 5th is equal to X times X over 0.188. 2.188. Okay, so you're going to take this times this, take a square root. We're going to get X, which is the hydroxide. Let's get that. Let's finish this one up and then we'll hang it up. Okay, so has anybody got hydroxide for me? Sherry, did you get a hydroxide? Hydroxide, anybody?
0.00182.
Point
00182.
0.00182 molar. And then POH is going to be minus the log of this number,
2.74.
2.74. And that is answer C, as in cat. Okay, but do you see how this one could have asked you for pH? Because you know pH plus POH is what? 14. So when you have a weak base problem, they could ask you, what's the hydroxide ion? What's the hydrogen ion? KW problem there. What's the pH or what's the POH? Likewise, for a weak acid problem, they could say, what's the hydrogen ion? What's the pH? What's the hydroxide? Or what's the POH? And what's the hardest thing that happens? There's a crossover. Like you have a KB problem, instead of asking you for POH, they ask, what's the pH? Okay, or over here, what's really weird, but not impossible, you got a weak acid, and instead of pH, they say, what's the pH? Okay, let's hang it up there. Tomorrow, what I'll do is I will start with problem 26 tomorrow morning at 10 a.m.